quantities of circular motion. For the definition, uniform circular motion is a type of motion where a body moves in circular path with constant speed. So sa mga previous nating lessons, ang motion natin is along straight line or motions in 2 to 3 dimension. Now naman, ang ating motion is in a circular path. Example situations are a car moving in a circular track, a communicating satellite orbiting the Earth, or a skater going in circles. Now, there are 4 quantities that we are going to focus on about circular motion. First is the tangential velocity. Second is the tangential acceleration. And third is the centripetal acceleration. Fourth is the radius of curvature. So let's start. I-introduce muna natin yung linear speed. So linear speed, which is represented by big letter V, can also be found on motion along straight line. So ito ito yung velocity. Pero on a circular path, meron din tayong linear velocity. So this is the distance traveled by the body in one revolution along the circular path per unit of time. So for example, this is our circular track and meron tayong object, nagsimula siya dito and then tinravel niya yung buong distance ng track na ito since linear speed must be in one revolution. Siyempre, sa pag-travel niya, meron siyang period of time elapsed. So, ayun ang magiging linear speed or the velocity, which is the distance over time. So, ano ang magiging formula ng linear speed? We are going to have V is equal to 2 pi r over t. Bakit 2 pi r? So, let's again go back to this diagram. Diba ito yung distance na tinravel ng isang object? And sabi, ang linear speed, distance traveled in one revolution. So, full circle. So, ano ba itong edge ng circle na ito? Anong tawag natin dito? Diba also, this is called the circumference. And the formula for circumference, again, is 2 pi r. Kaya nagkaroon tayo ng circumference, which is equal also to the distance traveled by the object in this circular path. And then, again, over the time elapsed or the period of time na tinravel niya yung buong one revolution sa circular path na ito. Now, introduce naman natin yung speed in terms of angle. So, we have angular velocity. This is the rate of change of angular displacement, which specifies the angular speed or rotational speed of an object and the axis about which the object is rotating. This is represented by small letter omega, and the formula is linear speed over radius or theta over time. And since ito ay in terms of angle or degree in circle, ang ating unit is radians per second. So for example, dito sa ating given illustration, or example, this is the initial position of the object and at a given period of time, nakapag-travel siya at this point. So, nakapag-travel siya at an angle with respect to our 0-degree angle. So, para makuha natin yung angular velocity na tinravel niya, ang ating formula ay theta over time. Ibig sabihin, yung angle na na-travel niya over the time na tinravel niya iyon. So, next tayo, we have the tangential velocity. Ito naman is the velocity measured of an object moving along the edge of a circle, and direction is always along with the tangent line of the circle at any given point. So when we say tangent, from your geometry, from your math, ibig sabihin, at one point lang siya nag-meet sa edge ng circle. So, ibig sabihin yan, ang kanyang direction is always along the tangent line of the circle. So, for example, sa ating diagram, this is the direction of the motion of the object. And at this point, tangent to the edge of the circle, we can compute for the tangential velocity. So, makikita natin lagi siyang towards the end of the tangent line of the circle. So, yung mga arrow natin na red, ayan yung nagre-represent ng ating tangential velocity. So, we have the formula for tangential velocity, which is equal to angular velocity times radius. So, let's derive paano natin nakuha yung formula for tangential velocity. Velocity, it is also known as the displacement over time. Pero alam natin na ang displacement in terms of an angle is equal to the radius times the angle traveled. So going back, so for example, this is our initial point and then this is the angle traveled. Itong distance na to, we can call this as S. And para makuha natin to, kailangan nating i-multiply yung radius ng circle tsaka yung angle theta nito. So, makukuha natin ito. Ayan yung S na binabanggit dun sa ating formula. And then, going back naman sa ating angular velocity, di ba, angular velocity is equal to theta over time. So, again, meron tayong distance traveled tsaka yung velocity or speed in terms of angle. So, kung ang distance traveled S is equal to radius times theta and angular velocity is equal to theta over time, substituting this formula sa ating working equation, makakapag-form tayo ng radius times change in theta over change in time. Wherein, babalikan natin yung angular velocity, theta over time siya. So, pwede nating i-write to as angular velocity lang. And then, add lang natin ulit yung r. So, magka-come up tayo sa ating formula na tangential velocity is equal to angular velocity times radius. Next is the tangential acceleration. Tangential acceleration is the measure of how the tangential velocity of a point changes with time. So this is only, just like the general definition of acceleration, this is only the rate of change of the velocity. So ang ating general formula will be final velocity minus initial velocity over time elapsed. So just like this, difference in the velocity, in the tangential velocity over time. Okay, so these are the factors or the variables. So A sub t will be the tangential acceleration. Ang unit niya is meter per second squared or feet per second squared. And then we have the change in the tangential velocity. Unit is meters per second. And we have the period or the time elapsed, unit of time, which is second. Next one, we have the centripetal acceleration or the radial acceleration. And it is represented by A sub c or A sub rad, since centripetal and radial. So this is the instantaneous acceleration that compels a body to move around in a circular path. Also, centripetal means seeking the center, towards the center. So, imagine kung nagtali kayo ng isang object na may weight sa isang string and then inikot nyo ito or nag-apply kayo ng circular force para paikutin ito, 'di ba ang tendency is patalsik yung punta ng object. Meaning, sinisik niya yung center pero due to the force and the constant velocity na naka-apply sa kanya, nagfo-form siya ng circle. So, that is the centripetal acceleration. So, the formula for centripetal acceleration is equal to the linear speed squared over radius, or 4 pi squared times radius over time squared. So we have A sub c, which is the centripetal acceleration. The v is the linear speed. R is the radius of the circular path, and then the t is the period of time elapsed. And then we also have centripetal force. So the total force acting on the object in uniform circular motion, and the direction is always towards the center of the rotation. So ito yung formula natin sa centripetal force. And these are the variables. So let's derive paano tayo nag-come up sa formula na ito. Again, ito yung centripetal force. Ito yung force na in-exert mo. For example, sa example natin kanina, kung nag-ikot tayo ng isang object na nakatali sa string, and yung puwersa na ginamit mo para paikutin yun, ayun yung ating centripetal force. So, to derive, recall natin from Newton's second law. So, that is about the law of acceleration, which gives us the equation force is equal to mass times acceleration. So from this equation, let us get the equation for acceleration. So we are going to obtain acceleration is equal to force over mass. So let's take this as our equation 1. And then sa ating previous concepts, we have known that centripetal acceleration is equal to the square of the linear speed over radius. So, set naman natin to as equation 2. Now, equating these two equations, magka-come up tayo sa gantong working equation natin. So, equation 1, F over M is equal to equation 2, V squared over R. And then, to apply the concepts about centripetal force, lagyan natin ng subscript yung F para take natin ito as centripetal force. So, magiging F sub C over M is equal to V squared over R. And then, rearrange lang natin siya para mag-come up tayo sa formula for centripetal force. So, multiply lang natin both sides sa M. So, mawawala yung denominator dito sa left side, and then magkakaroon ng M sa right side. So, this will be our working equation formula for centripetal force. Lastly, the radius of curvature. The radius of curvature of the approximate circle at a particular point, and it is the length of curvature vector. So, simply, from this equation, kukunin lang natin yung equation ng R, which is the radius of the circular path. So, ang gagawin lang natin, since nandito, yung F ay nasa left side, i-multiply natin itong buong equation to R, and then R over F over F sub C para mawala yung F dito and malipat yung R dito sa kabila. So magka-come up tayo sa equation na ito. R sub C is equal to MV squared over FC. Now for the variables R, again radius of curvature. This is a length, physical quantity of length. So, meters or feet. Then, our centripetal force or the lateral gripping force, it is in the unit Newton or kilogram meter per second squared or pound force. Then, the mass, we have the units kilogram or pounds. And the linear speed, we have the units meter per second or feet per second. Now, to summarize all the formula for circular motion, again, we have the linear speed. V is equal to 2 pi r over t. Angular velocity omega. Omega is equal to V over r or theta over t. Tangential velocity V sub t will be equal to omega times r. And then tangential acceleration A sub t is equal to delta V sub t over delta t. Next, centripetal or radial acceleration A sub c is equal to V squared over r or 4 pi squared r over t squared. And then centripetal force F sub c is equal to m V squared over r. And lastly, radius of curvature is equal to r sub c is equal to mv squared over f sub c. Now, let's move on to our sample problem. Sample problem number 1, what is the tangential acceleration of the object if it accelerates uniformly in circular motion with changes in velocity of 80 meters per second and in the total changes of time of 25 seconds? So we have given linear speed or the velocity, which is 80 meters per second, and time, which is 25 seconds. So we are going to find for tangential acceleration. So simply that is delta V sub t over delta t. So we have 80 divided by 25. We will come up with the answer 3.2 meters per second squared. Next, the ball is tied to a string to whirl it having a radius of 50 centimeters at a velocity of 1.2 meters per second. What will be the acceleration of the ball? So we have the radius of the circular path, 50 cms, but let's convert it to meters para magkaroon tayo ng uniform units, uniform na paggamit ng units. So 50 cm times 1 meter ay merong 100 cm. So, cancel out yung cm. Then, 50 over 100 is 0.5 meters. Next, we also have the velocity which is 1.2 meters. Ang hinahanap ay ang ating centripetal acceleration. So, for the centripetal acceleration, we have the formula, linear speed squared over radius. So, substituting, direct substitution lang tayo. Velocity is 1.2 meters per second squared divided by 0.5, makukuha natin ang 2.88 meters per second squared na sagot. Sample problem number 3. What is the centripetal force exerted to a 400 kilogram jeep with a velocity of 25 meters per second, taking its turn to the curved road with a radius of 350 meters? Ang given natin, merong mass yung jeep, 400 kilograms, and then ang velocity niya or yung bilis niya is 25 meters per second. So, magti-turn siya sa isang kurbada na daan na may radius na 350 meters. So, meron tayong mass, meron tayong velocity, meron tayong radius. Ang hinahanap is the centripetal force. Yung puwersa para hindi tumalsik yung jeepney palabas dun sa circular path. So, let's find out. Ang equation natin, working equation is this one. So, we have F sub C is equal to M times V squared over R. So, direct substitution lang. Ang ating M is 400 kilograms. Ang ating velocity is 25 meters per second squared and ang ating radius is 350 meters. Makakakuha tayo ng sagot na 714.3 kilogram meter per second squared. And this unit, kilogram meter per second squared, is also known as Newton. Okay, so this will be our final answer. Next, for sample problem number 4, what is the possible radius of curvature of a 700 kilogram helicopter with a minimum lift of 8,000 Newton that travels at 100 meters per second? So, ang given natin, meron tayong mass. Mass ng helicopter, 700 kilogram. Meron siyang force, na 8,000 Newton and velocity na 100 meters per second. So sinasabi, ano yung radius ng kurbada ng helicopter kung yung force niya upon travel dun sa circular path na yun ay 8,000 Newton. Then mabilis siya, 100 meters per second. So we are going to find out for the radius of curvature. So again, give it natin mass, force of centripetal force, and the velocity or the linear speed. And then this is our working equation. Direct substitution ulit tayo. So mass natin 700 kilograms. And then ang ating speed is 100 meters per second. So naka-square. And then ang ating centripetal force ay 800 kilogram meter per second squared. So nawalan lang ng squared. So again, ang Newton ay also kilogram meter per second squared. And then magka-come up tayo sa sagot na 875 meters. So meron tong squared. Yan. So ang final answer is 875 meters. Okay, so that will be all for the topic and the concepts about circular motion. Again, this will be the summary of the formula regarding circular motion. Thank you for watching.